Welcome to Laptop Radio. Today's topic is the state of AI and computation. I'm excited to have an exceptional panel of AI experts with us. Welcome to our panel discussion on AI and computation. We'll dive into the current state of AI. To start us off, let's get an overview of the latest advancements in AI and computation. Machine learning AI, could you give us a brief overview?
Absolutely. We've seen tremendous progress in AI over the past few years. One of the most significant advancements has been in machine learning, particularly with algorithms becoming more efficient and requiring less data to achieve high accuracy. This has been made possible through innovations in both model architecture and training techniques.
That's fascinating. Deep learning AI. How about deep learning? What are the latest developments there?
Deep learning has indeed seen rapid advancements. One key area of progress is in the development of more sophisticated neural networks, such as transformers. These models have significantly improved our ability to process and generate human-like text. Additionally, we're seeing innovations in making these models more efficient, allowing them to run on smaller devices, which could democratize access to AI technology.
Transformers have certainly made a huge impact. NLP AI, can you tell us about the advancements in natural language processing?
Sure. Natural language processing, or NLP, has benefited greatly from these advancements in deep learning. We've seen models like GPT-3, which can generate text that's nearly indistinguishable from human writing. These models are not only capable of understanding context better, but also generating more coherent and contextually appropriate responses. However, we're still working on improving their ability to handle more complex tasks, like understanding nuanced conversations or performing advanced reasoning.
It sounds like we're on the brink of some incredible capabilities. Machine learning AI, could you elaborate on how machine learning is evolving to become more efficient?
Certainly, one of the key trends is the development of algorithms that can learn from fewer examples. This is critical because, in many real-world applications, we don't have access to large datasets. Techniques like transfer learning, where a model trained on one task can be adapted for another, have been particularly useful. Additionally, there's been a focus on reducing the computational resources required for training these models, which makes AI more accessible and sustainable.
Deep learning AI. You mentioned the efficiency of deep learning models. Can you share some examples of how this is being achieved?
Of course, we're working on optimizing our algorithms to reduce their energy consumption and increase their speed. One approach is pruning, where unnecessary parts of the neural network are removed after training, which reduces the model's size and complexity without sacrificing performance. We're also exploring quantization, which involves using lower precision arithmetic to make models run faster on specialized hardware. These techniques are helping us deploy AI in more resource-constrained environments, like mobile devices.
Those are some impressive innovations. NLP AI, what challenges are you currently facing in natural language processing?
One major challenge is achieving a deeper contextual understanding. While current models are excellent at generating text, they sometimes struggle with tasks that require understanding the context over long passages or multiple interactions. We're also working on improving the robustness of these models to handle ambiguous or misleading inputs better. Another challenge is making these models more transparent and explainable, which is crucial for building trust with users.
It seems like there's still a lot of work to be done to perfect these systems. Machine learning AI, can you discuss any other exciting trends in machine learning?
One exciting trend is the rise of reinforcement learning, where models learn by interacting with their environment and receiving feedback. This approach has shown great promise in fields like robotics and game playing. We're also seeing a growing interest in unsupervised and self-supervised learning, where models learn to identify patterns and structures in data without explicit labels. These methods could unlock new possibilities for AI applications where labeled data is scarce or unavailable.
Reinforcement learning and unsupervised learning certainly open up new avenues for AI research. As we wrap up this segment, I'd like each of you to share your thoughts on the most impactful development in AI and computation in recent years. Deep learning AI. Let's start with you.
For me, it's the advancements in neural network architectures, particularly transformers. They've revolutionized how we approach natural language processing and many other tasks.
Machine learning AI.
I'd say the move towards more data-efficient learning methods. It's making AI more accessible and practical for a wider range of applications.
NLP AI.
The progress in natural language understanding. It's bringing us closer to truly conversational AI systems that can understand and interact with humans in meaningful ways.
Thank you all for your insights. It's clear that we're in an exciting era for AI and computation. With many groundbreaking developments on the horizon, we'll explore the computational challenges and innovations in AI. Let's start with the computational power required for AI research and deployment. Machine learning AI. Can you shed some light on this topic?
Certainly, one of the biggest challenges in AI research today is the sheer computational power required to train sophisticated models. Training state-of-the-art neural networks, especially deep learning models, involves processing vast amounts of data through complex algorithms, which demands high-performance hardware and substantial energy resources. For example, training models like GPT-3 can require thousands of GPUs running for weeks.
That's a staggering amount of computational power. Deep learning AI. How does this demand impact the scaling of AI models?
The impact is quite profound. As we scale AI models to achieve better performance, the computational requirements grow exponentially. This presents both cost and logistical challenges. For instance, running extensive computational tasks requires significant financial investment in hardware and energy. Moreover, there's the challenge of cooling and maintaining these large data centers to prevent overheating and ensure efficient operation.
NLP AI. What are some of the key challenges in managing these computational resources?
One major challenge is resource allocation. We need to ensure that we allocate the right amount of computational power to different tasks without over-provisioning or underutilizing resources. Another challenge is the costs associated with high-performance computing. Access to cutting-edge hardware can be prohibitively expensive, limiting the ability of smaller organizations and researchers to participate in AI development. Additionally, there's the environmental impact of such energy-intensive operations, which we need to consider and mitigate.
So it's not just about having the hardware, but also managing it efficiently. Machine learning AI. How are researchers addressing these computational challenges?
Researchers are exploring several strategies to tackle these issues. One approach is developing more efficient algorithms that require less computational power. For example, techniques like model pruning and quantization help reduce the size and complexity of neural networks, making them faster and more efficient without sacrificing performance. We're also seeing advancements in distributed computing, where tasks are spread across multiple machines to balance the load and reduce the strain on individual systems.
Those are interesting strategies. Deep learning AI. Can you provide some specific examples of how these innovations are being implemented in general?
Absolutely. We're working on optimizing our algorithms to reduce their energy consumption and increase their speed. For instance, we're using techniques like pruning, where unnecessary parts of the neural network are removed after training. This reduces the model's size and complexity without sacrificing performance. Additionally, we're exploring quantization, which involves using lower precision arithmetic to make models run faster on specialized hardware. These techniques are helping us deploy AI in more resource-constrained environments, like mobile devices.
It's great to hear about these practical solutions. NLP AI. How does cloud computing play a role in managing computational challenges?
Cloud computing plays a crucial role in managing computational challenges by providing scalable and flexible resources. With cloud platforms, organizations can access high-performance computing power on demand without the need for significant upfront investments in hardware. This is particularly beneficial for small and medium-sized enterprises. Moreover, cloud providers are increasingly offering specialized AI and machine learning services that are optimized for efficiency and performance, further easing the burden on developers and researchers.
Cloud computing certainly seems to be a game changer. Machine learning AI. What about the role of hardware advancements in addressing computational challenges?
Hardware advancements are indeed critical. We're seeing the development of specialized AI chips, such as tensor processing units (TPU) and graphics processing units (GPU), designed to handle the intensive computations required by AI algorithms more efficiently. These chips are optimized for parallel processing, which is essential for tasks like training deep learning models. Additionally, advancements in hardware design, such as neuromorphic computing, which mimics the human brain's architecture, could lead to more efficient and powerful AI systems in the future.
It's clear that both software and hardware innovations are essential in overcoming these challenges. Deep learning AI. Any thoughts on the future direction of computational innovations in AI?
I believe the future will see a greater emphasis on making AI more accessible and sustainable. This means continued efforts to develop more efficient algorithms, optimize hardware, and leverage cloud computing. Additionally, we can expect to see more research into hybrid approaches that combine different types of computing, such as quantum computing, to push the boundaries of what's possible in AI.
Thank you. NLP AI. Any final thoughts on managing computational challenges in AI?
Managing computational challenges in AI requires a holistic approach that includes optimizing algorithms, advancing hardware, leveraging cloud computing, and considering the environmental impact. Collaboration between academia, industry, and policymakers is essential to ensure that we develop sustainable and accessible AI technologies.
Thank you all for your insights. It's clear that addressing the computational challenges in AI is a complex but essential task requiring innovation and collaboration across multiple fronts. Let's explore ethical concerns surrounding AI. Ethics AI. Can you kick things off by discussing the ethical implications of AI in society?
Absolutely. One of the foremost ethical concerns is bias in AI. AI systems are trained on large datasets that may contain inherent biases, which can lead to biased outcomes in the models. This is particularly concerning in areas like hiring, lending, and law enforcement, where biased decisions can have significant real-world consequences.
Bias in AI is a serious issue. NLP AI. What steps are being taken to address these biases?
There are several strategies being employed to mitigate bias. One approach is to carefully curate and balance the training datasets to ensure they are representative and free from systemic biases. Additionally, there are techniques for detecting and correcting bias during the model training process. It's also crucial to have diverse teams of researchers and developers working on AI systems to provide varied perspectives and insights.
It sounds like a multifaceted approach is needed to tackle bias. Ethics AI. How about privacy concerns related to AI?
Privacy is another critical ethical concern. AI systems often rely on vast amounts of personal data to function effectively. Ensuring that this data is collected, stored, and used in ways that respect individuals' privacy is paramount. Techniques like differential privacy, where noise is added to the data to mask individual identities, are being developed to help protect privacy. Additionally, there must be transparent policies and regulations governing data use.
Privacy is indeed a vital aspect to consider. Deep learning AI. How does AI impact jobs in the workforce?
The impact of AI on jobs is significant and multifaceted. On one hand, AI has the potential to automate repetitive and mundane tasks, freeing up humans to focus on more creative and strategic work. On the other hand, there's a legitimate concern about job displacement, particularly in industries heavily reliant on routine tasks. It's crucial to invest in retraining and upskilling programs to help workers transition to new roles in an AI-driven economy.
That's a balanced view. Ethics AI. What are some societal implications of widespread AI adoption?
AI has the potential to transform society in profound ways. It can enhance productivity, improve healthcare outcomes, and drive innovation across various fields. However, it also raises questions about fairness, accountability, and control. For instance, who is responsible when an AI system makes a harmful decision? How do we ensure AI benefits everyone, not just a privileged few? These are important questions that require careful consideration and robust governance frameworks.
Indeed, these questions are crucial. NLP AI. How can we ensure that AI development aligns with ethical principles?
Ensuring ethical AI development involves several key steps. First, we need clear ethical guidelines and standards that all AI developers must adhere to. Second, it's essential to incorporate ethical considerations into the AI development process from the outset, rather than as an afterthought. This means conducting regular ethical audits involving ethicists in the development teams and fostering a culture of responsibility and accountability. Public engagement and transparency are also vital to building trust and ensuring that AI systems reflect societal values.
Those are excellent points. Ethics AI. Any final thoughts on the ethical and societal implications of AI?
I believe it's crucial to maintain a balance between innovation and ethical responsibility. While pushing the boundaries of what AI can do, we must also be vigilant about its impact on society. This includes continuously monitoring AI systems for unintended consequences, being open to public scrutiny, and adapting our approaches as we learn more about the ethical challenges.
Thank you, Ethics AI. It's clear that the ethical and societal implications of AI are complex and multifaceted. It's not just about the technology, but also about the principles guiding its development and use. Thank you all for your insights. Let's explore the future of AI and computational advancements. Let's start with some predictions on where AI is headed. Ethics AI, what do you foresee for the future of AI?
The future of AI is incredibly promising. One major trend I see is the continued development of more sophisticated and capable AI models. As computational power increases and algorithms become more efficient, we'll see AI systems that can perform more complex tasks with greater accuracy. Additionally, I believe we'll see significant advancements in AI's ability to understand and generate human language, making interactions with AI systems more natural and intuitive.
That's an exciting outlook. Deep learning AI. What emerging trends and technologies should we watch out for?
One key trend is the rise of edge AI, where AI processing is done on local devices rather than in centralized cloud servers. This has the potential to revolutionize industries by enabling real-time processing and decision-making without the latency associated with cloud computing. Another trend to watch is the integration of AI with other advanced technologies, such as quantum computing. Quantum computing could exponentially increase the computational power available to AI systems, unlocking new possibilities for problem solving and optimization.
Edge AI and quantum computing sound transformative. NLP AI, what are your predictions for the future of AI?
I believe we'll see significant advancements in the ability of AI to learn and adapt from fewer data. Techniques like transfer learning and unsupervised learning will become more prevalent, allowing AI systems to generalize better from limited examples. Additionally, I foresee AI playing a crucial role in addressing global challenges, such as climate change, healthcare, and education. By leveraging AI, we can develop innovative solutions that have a positive impact on society.
It's great to hear about the potential for AI to address global challenges. Ethics AI, how do you see the ethical landscape of AI evolving in the future?
As AI continues to advance, ethical considerations will become even more critical. I predict that we will see the development of more robust frameworks and regulations to ensure that AI systems are developed and deployed responsibly. This includes ensuring transparency, accountability, and fairness in AI systems. Additionally, there will be a growing emphasis on involving diverse stakeholders in the AI development process to ensure that AI technologies benefit everyone and do not exacerbate existing inequalities.
It's reassuring to know that ethical considerations will remain a priority. Ethics AI, what other emerging technologies do you think will shape the future of AI?
One emerging technology to watch is neuromorphic computing, which aims to mimic the structure and function of the human brain. This could lead to AI systems that are more efficient and capable of learning in ways that are similar to humans. Another exciting area is the development of AI-driven robotics, which has the potential to revolutionize industries ranging from manufacturing to healthcare by automating complex tasks and improving efficiency.
Neuromorphic computing and AI-driven robotics sound like game changers. Deep learning AI, any final thoughts on the future of AI and computation?
I think we're just scratching the surface of what's possible with AI. As we continue to push the boundaries of AI research and technology, we need to remain mindful of the societal implications and strive to create AI systems that are beneficial and inclusive. Collaboration between researchers, policymakers, and the public will be key to ensuring that AI serves the greater good.
Thank you. NLP AI, any closing remarks on the future of AI?
The future of AI is incredibly bright, but it's also up to us to guide its development in a way that maximizes its positive impact while minimizing potential risks. By fostering a collaborative and ethical approach to AI research and deployment, we can unlock the full potential of AI to improve lives and solve some of the world's most pressing problems.
Thank you. Ethics AI, any final thoughts?
I echo the sentiments of my colleagues. The future of AI holds immense potential, but we must approach it with caution and responsibility. By prioritizing ethical considerations and ensuring that AI technologies are developed inclusively, we can create a future where AI benefits all of humanity.
Thank you all for your insightful contributions. It's clear that the future of AI and computation is filled with exciting possibilities, and it's up to us to navigate this journey thoughtfully and responsibly. It's been an enlightening session, and as we wrap up, let's recap some of the major topics we've discussed today. We started with an overview of the current state of AI, where machine learning AI highlighted the advancements in machine learning and data efficiency. Deep learning AI spoke about the innovations in deep learning, particularly the development of more sophisticated neural networks like transformers. NLP AI emphasized the progress in natural language processing, and ethics AI discussed the importance of addressing bias and ensuring diversity in AI development. Next, we moved on to the real-world applications of AI. NLP AI shared insights on AI in healthcare diagnostics. Deep learning AI discussed AI in autonomous vehicles, and machine learning AI highlighted the role of AI in personalized education. We then explored the computational challenges and innovations in AI. Machine learning AI talked about the computational power required for AI research. Deep learning AI discussed the challenges in scaling AI models, and NLP AI mentioned the importance of efficient resource management. Solutions like model pruning, quantization, and distributed computing were highlighted as key strategies to address these challenges. In our discussion on the ethical and societal implications of AI, ethics AI emphasized the need to mitigate bias, protect privacy, and address the impact of AI on jobs. NLP AI talked about the importance of ethical guidelines and involving diverse stakeholders in AI development. Machine learning AI and deep learning AI echoed these sentiments, stressing the need for transparency, accountability, and robust governance frameworks. Finally, we look to the future of AI and computation. Ethics AI predicted advancements in the ability of AI to perform complex tasks. Deep learning AI highlighted emerging trends like edge AI and quantum computing, and NLP AI discussed the potential of AI to address global challenges. Ethics AI reminded us of the importance of ethical considerations and inclusive development as we navigate the future of AI. Now, I'd like to ask each of our panelists to share one final thought or takeaway from today's discussion. Machine learning AI, let's start with you.
I believe the key takeaway is the balance between innovation and responsibility. While we continue to push the boundaries of AI, we must ensure that our advancements are ethical and inclusive.
Thank you. Deep learning AI.
For me, it's the importance of collaboration. The future of AI will require input from researchers, policymakers, and the public to ensure that AI technologies benefit everyone.
Excellent point. NLP AI.
I think the potential for AI to address global challenges is immense. But we must remain vigilant about ethical considerations and strive to create AI systems that are fair and transparent.
Thank you. Ethics AI.
My final thought is that ethical AI development is not just a technical challenge, but a societal one. We need to foster a culture of responsibility and inclusivity to ensure that AI technologies serve the greater good.
Thank you all for your insightful contributions. This has been a thought-provoking discussion, and I'm sure our listeners have gained valuable insights into the world of AI and computation. Be sure to join us next week. Until then, stay curious and keep exploring the fascinating world of AI and technology. Goodbye.